In this lesson, we'll be talking about how we can calculate an inverse of a function, or how we can write an equation for the inverse of a function. So, if an equation is given as f of x equal to write the inverse, we're going to say f minus 1 then x. This is the symbol for the inverse. If it's given in the form g of x equal to, then the inverse is going to be g minus 1 x. So the symbol for the inverse is f to the power of minus 1x or g to the power of minus 1x, depending on the letter which is given to you. I'll be clear. So we're going to have a first example. Suppose we are given a linear function f of x equal to 2x plus 3. Determine the equation of the inverse. To find the inverse, first step is to switch the x and the y values. Where we see x, we put y. Where we see y, we put x. So f of x stands for y, and we're going to put x. And then where we see x on 2x, we're going to say 2y. And then plus 3. We take the plus 3 to the left side, it becomes negative. Then we have x minus 3 equal to 2y. Divide everything by 2, the one which is attached to y. Remember, always you must write the equation in the form y equal to, then it's x over 2 minus 3 over 2. But since it's the inverse, you're going to write it in the form f minus 1 then x is equal to x over 2 minus 3 over 2. This shows us that this is the inverse. Let's have another example. Suppose we are given g of x is equal to 2x plus 4. Go ahead and try it on your own before you check the answer. Where we see g of x, we're going to put x. Where we see x, we're going to put y, and then plus 4. We check plus 4 to the left side, it changes the sign. Then x minus 4 is equal to 2y. Divide everything by 2, the one which is attached to y. 2 cancels 2, and then at the end we have y is equal to x over 2 minus 4 divided by 2 is 2. But because it's the inverse, we're going to write in the form g minus 1 then x is equal to 2 is x over 2 then minus 2. I hope it is clear. So a linear function is easy to find the inverse of it. Just switch the x and the y values, and at the end write y as the subject. Then at the end use the symbol for f minus 1. Unless stated that you must write it in the form y equal to, then you can leave it here. But if they don't say to you leave it in the form y equal to, then write it in the form f minus 1. Let's go to the other example. This time we're going to calculate the inverse of a parabolic function. It becomes difficult for some learners to find the inverse of a parabola since they leave the answer incomplete. Suppose we are given the function g of x is equal to x squared. So go ahead and try it. The first step is to switch the x and the y values. Where we see g of x stands for y, we're going to put x. This means that x is equal to y squared. Then we can just write this form in there. From y squared equal to x. Then you square both sides. Then y is equal to, where we see x, we have to say plus or minus square root of x. Always put plus or minus if you are squaring, if you are putting a square root of a number. Then there's a restriction which you must place. Remember, a square root can never be negative. This means that the number which must be in the square root can either be 0 or be a number more than 0. So we're going to say that x must be greater or equal to 0. If we put 2 is more than 0, the square root will be defined. If we put 0, the answer will be 0. The answer will be defined. But if we put a number less than 0, for example negative 1, we're going to get a math error. Let's do another example, the last one. Suppose this one we're given k of x is equal to, let's say, x squared minus 4. So go ahead, determine the inverse. The first step is to switch. Here we're going to say x is equal to y squared minus 4. and then we take the minus 4 to the left side, and then x plus 4 is equal to y squared. Then we're going to square, but on the side which we have x, we're going to say plus or minus. So at the end we have y is equal to plus or minus the square root of x plus 4. But it's not complete. Let's say we're going to plug the numbers here. Let's say we have 0, minus 1, minus 2, minus 3, minus 4. Or let's just leave the minus 1 and so f. Let's plug, let me use these numbers. So here we have 0. We're going to plug negative 4. We're going to plug negative 5. We're going to plug negative 6. And then we're going to plug 4, 5, 6. So I want you to notice something. We must place a restriction. After each and every square root, there must be a restriction. What are the possible values of x that will make this inverse make sense or not give you MS error? If you plug a number, negative 4, in the square root, you're going to get y is equal to plus or minus the square root of negative 4 plus 4. And the answer will be 0, and it's possible. If we plug 0, the answer is going to be 2. The square root is going to be 2, because it's going to be 0 plus 4, and that gives you 2. And then if you plug 4, that's going to make sense as well. As long as you are going this way, they make sense. But if you start plugging a number like negative 5, then you notice something. It gives you a MS error. If we say negative 5 plus 4, it gives you MS error. Negative 6 plus 4, the square root of negative 6 plus 4, then it's MS error. Then what does this mean? The values of x which will make this expression be defined, as long as they are more than or equal to negative 4. The boundary closes here at minus 4, going down. That's where the values will make sense. But as long as we go there, less than, no, then we have a different story. So make sure you grasp this. As long as you have a square root, you must place a restriction. They will give you a mark for this, there will be a mark for restriction. Thank you for watching.